Welcome to qnawire.
Hi, so in this case what we have is the following reaction. 2 moles of hydrogen gas plus oxygen gas are going to produce 2 moles of water gas. And we're told that the delta H for this reaction is equal to minus 483.6 kilojoules. It's actually like kilojoules per mole of reaction, but you can leave it as kilojoules directly. So we want to calculate the following quantities. First of all, we want to know what is the delta S for the system. And remember that delta S for the system is going to be equal to the entropies of the products minus the entropies of the reactants. And each of them are going to multiply by their stoichiometric coefficient. Let's remember as well that compared to what happens with delta H and delta G, the entropies of the standard state of substances are not going to be equal to zero. So, in this case, what this is going to look like is 2 times standard entropy of water as a gas minus 2 times the standard entropy of hydrogen as a gas minus the standard entropy of oxygen as a gas. So the values that I'm going to be employing are from Overby and Chang's book of chemistry, 13th edition, and they are as follow. For water, what we have is 2 times 188.7 joules. It is given in joules per mole Kelvin, but since we are multiplying by 2 mole, we can directly put joules over Kelvin. Well, let's put directly in mole Kelvin. Minus 2 times the value for hydrogen gas is 131.0 joules per mole Kelvin. And finally, the value for oxygen is 205 joules per mole Kelvin. Again, the moles are going to cancel out because we're multiplying by the stoichiometric coefficients. So the result is minus 91 joules per Kelvin. And this would be the entropy of the system. Now, we want to know what is going to be the entropy of the change of entropy for the surroundings. And for the surroundings, we know that the entropy is related to the heat, and that heat is related to the enthalpy. So we can write down directly that this is equal to minus delta H for the system, in this case the delta H for the reaction, over T. So minus with minus becomes plus. This becomes 483.6 kilojoules. So we need to multiply this by 1000. 1, 2, 3 joules divided by my temperature in Kelvin, that is 298 Kelvin, giving 1622.82. Let's round it out to two significant figures. And this is the same, joule per Kelvin. So, with this, we can calculate the delta S of the universe, and that is the sum of delta S of the system with delta S of the surroundings, giving us 1531.82 joules per Kelvin. And that would be all. Thank you very much.